Cours d'Analyse de l'École Royale Polytechnique, I.re Partie.Analyse algébrique is a seminal textbook in infinitesimal calculus published by Augustin-Louis Cauchy in 1821. The article follows the translation by Bradley and Sandifer in describing its contents. Introduction. On page 1 of the introduction, Cauchy writes, "In speaking of the continuity of functions, I could not dispense with a treatment of the principal properties of infinitely small quantities, properties which serve as the foundation of the infinitesimal calculus." The translators comment in a footnote. It is interesting that Cauchy does not also mention limits here. Cauchy continues, "As for the methods, I have sought to give them all the rigor which one demands from geometry, so that one need never rely on arguments drawn from the generality of algebra. Preliminaries." On page 6, Cauchy first discusses variable quantities and then introduces the limit notion in the following terms. When the values successively attributed to a particular variable indefinitely approach a fixed value in such a way as to end up by differing from it by as little as we wish, this fixed value is called the limit of all the other values. On page 7, Cauchy defines an infinitesimal as follows. When the successive numerical values of such a variable decrease indefinitely, in such a way as to fall below any given number, this variable becomes what we call infinitesimal, or an infinitely small quantity. Cauchy adds, a variable of this kind has 0 as its limit. On page 10, Bradley and Sandifer confuse the verse cosine with the coverse sign. Cauchy originally defined the sinus versus as siv equals 1 cos and the cosinus versus as cosiv equals 1 sin. In the translation, however, the cosinus versus are incorrectly associated with the verse cosine rather than the coverse sign. The notation lim is introduced on page 12. The translators observe in a footnote, the notation lim for limit was first used by Simon Antoine Jean-Louis Euler in Lullier 1787. 31. Cauchy wrote this is lim in Cauchy 1821. 13. The period had disappeared by Cauchy 1897. 26. Chapter 2. This chapter has the long title, On Infinitely Small and Infinitely Large Quantities, and on the continuity of functions. Singular values of functions in various particular cases. On page 21, Cauchy writes, "We say that a variable quantity becomes infinitely small when its numerical value decreases indefinitely in such a way as to converge towards the limit 0. On the same page, we find the only explicit example of such a variable to be found in Cauchy, namely on page 22. Cauchy starts the discussion of orders of magnitude of infinitesimals as follows. Let be an infinitely small quantity, that is a variable whose numerical value decreases indefinitely, when the various integer powers of, namely enter into the same calculation. These various powers are called, respectively, infinitely small of the first, the second, the third order, etc. Cauchy notes that the general form of infinitely small quantities of order n will be or at least. On pages 23 to 25, Cauchy presents 8 theorems on properties of infinitesimals of various orders. Section 2.2. This is entitled Continuity of Functions. Cauchy writes, if beginning with a value of x contained between these limits, we add to the variable x an infinitely small increment, the function itself is incremented by the difference, and states that the function f is a continuous function of x between the assigned limits if, for each value of x between these limits, the numerical value of the difference decreases indefinitely with the numerical value of. Cauchy goes on to provide an italicized definition of continuity in the following terms. The function f is continuous with respect to x between the given limits if, between these limits, an infinitely small increment in the variable always produces an infinitely small increment in the function itself. On page 32, Cauchy states the intermediate value theorem. Sum theorem. In Theorem I in section 6.1, Cauchy presents the sum theorem in the following terms. When the various terms of series of functions of the same variable x, continuous with respect to this variable in the neighborhood of a particular value for which the series converges, the sum S of the series is also a continuous function of x in the neighborhood of this particular value. Here the series appears on page 86. Bibliography. Cauchy, Augustin-Louis. Analyse algébrique. Cours d'analyse de l'École Royale Polytechnique 1. Le Primary Royal, des Beaux-Frères, Libraires du Roi et de la Bibliothèque du Roi. Retrieved 7 November 2015. Bradley, Robert E., Sandifer, Edward 2009. Buchwald, J.Z., ed. Cauchy's Cours d'Analyse. An annotated translation. Sources and studies in the history of mathematics and physical sciences. Cauchy, Augustin-Louis. pp. 10, 285. DOI 10.1007 978 1 4419 0549 9. ISBN 978 4419 0548 2. LCCN 2,009,932,254. 1,441,905,499, 978 1 4419 0549 9. Retrieved 9 November 2015.